Hi, this is Priyankesh and welcome to the second trial class of IGIDR Entrance Exam. In this class, I'm going to cover the topic differentiation, which is in continuation with the first part. So let's begin. So let me quickly begin with the syllabus. In the last class, I have covered sum and difference rule, and I have also covered product rule, quotient rule, chain rule, and the difference of log, exponential, and implicit function. This I have covered. Now today I am going to cover parametric form, higher order derivative, first principle derivative rule, and the nature of differential equation, then inverse function. These two topics I will cover in the next part of the video. So let's quickly start with the parametric form. Here one thing I would like to bring in your attention that till now we have covered all the differentiation which are in the form of y equals to fx, but sometimes the question may be given in the form of, let's say, x is a function of f of t and y is a function of f of t, and they might ask you to find out dy by dx and d2y by dx2. So such question can be asked, and another could be, let's say, x is a function of y and y is a function of z. So they might ask you to find out the differentiation of x with respect to z. So such question can be asked and which will be covered in the parametric form. Okay. So what I'm going to do here, I'm going to give you some examples so that you can understand. Let's say the first example is x equals to a cos t and y equals to b sin t. Okay, so let first differentiate x with respect to t. So this will come out to be as a minus a sin t, because differentiation of cos t is minus sin t. Now let's differentiate y with respect to t. So this will become, let's say, differentiation of sin t is cos t. Okay. Now to find out dy by dx, what we will have to do, simply we can write it like that, dy by dt upon dx by dt. So in that way we can find out. Now put the values of both the derivatives. So this will come out to be, here it is b cos t, and here it is a minus a sin t. Okay, so this will come out to be minus b upon a cot t. Okay, so this will be our answer. Okay, so let's move to the next question, that is question 2. So here it is x equals to a in a bracket t plus sin t, and the other function is y equals to a 1 minus cos t. We have to find dy by dx. So to find dy by dx, what we will do, we will simply differentiate x with respect to t. So this will come out to be a in a bracket 1 plus differentiation of sin t is cos t. Okay, we'll differentiate y with respect to t. So this will come out to be a in a bracket differentiation of 1 is 0 and differentiation of cos t will be minus sin t. So this will become plus sin t. Now to find dy by dx, it will come out to be dy by dt divided by dx by dt. Okay, now put the values. So this is a sin t whole upon a in a bracket 1 plus cos t. Okay, so here a and a gets eliminated. Now use half angle formula. So sin t will come out to be 2 sin t by 2 into cos t by 2 whole upon 1 plus 2 cos square t by 2 minus 1. So first eliminate 1 and 1, and after this elimination we can eliminate 2 and 2, and we can eliminate 1 cos t by 2. So this will become sin t by 2 on cos t by 2. This will become tan t by 2. So this will be your final answer. Okay, let's move to the next question 3. So this is y equals to under root a cos inverse t and x equals to under root a sin inverse t. Okay, So we have to find dy by dx here. So for that, let's differentiate y with respect to t. So as we already know that differentiation of root x is 1 upon 2 root x. So this will come out to be 1 upon 2 root a to the power cos inverse t. And again by applying chain rule, and we'll use the formula ddx of a to the power x, that is a to the power x ln a. Okay, so we are going to use it here. So this will come out to be a to the power cos inverse t and ln a. Okay, and then we'll again by chain rule we'll differentiate cos inverse t. So this will come out to be -1 upon under root 1 minus x square. Okay, similarly we'll differentiate x with respect to t. So this will come out to be 1 upon 2 root a to the power sine inverse t multiplied by same with the same rule. I'll differentiate. So this will come out to be a to the power sine inverse t into ln a. Okay, this is ln a multiplied by differentiation of sine inverse t, that is 1 upon under root 1 minus x square. Okay, so now divide both sides. So on the left hand side we'll get dy by dx, and on the right hand side there are some common terms which we can eliminate. So ln a gets eliminated, under root 1 minus x square, 1 minus x square gets eliminated, 2 and 2 gets eliminated. Okay, now let's solve it. So here this minus will come. Okay, so minus, and this root a to the power cos inverse t and a to the power cos inverse t will become under root a to the power cos inverse t by after solving. Okay, similarly in denominator, after solving a to the power sine inverse t and a to the power sine inverse t, so this will become a to the power sine inverse t. And as you know, this value represents y and this value represents x, so this will be your final answer. Let's move to the next question, that is question number I think 4. Yeah, so x equals to a cos t plus t sin t. Okay, and y equals to, this is plus. Okay, keep this thing in mind. And y equals to a sin t minus t cos t. Okay, this is also in a bracket. So now let's differentiate x with respect to t, and we have to find dy by dx here and d2y by dx2 as well. We'll tell you later what is d2y by dx. So first find dy by dx. Okay, so dx by dt, so this will come out to be a, and differentiation of cos t is minus sin t, plus we'll apply product rule, that is first into second. So first function differentiation of second, that is cos t, plus we'll write sin t as it is, and differentiation of t is 1. Okay, so now let's solve it. So this will come out to be a minus sin t plus t cos t. Okay, plus t cos t and plus sin t. Okay, now sin t gets eliminated, so this will come out to be a t cos t. Okay, then dy by dt, so this will come out to be a, differentiation of sin t is cos t. Okay, minus, now we'll again apply first second rule, that is product rule. So t, differentiation of cos t is minus sin t, and then plus, this is minus. Okay, plus this will come out to be cos t into 1. Okay, 1. Yeah, so now let's solve it. So this will be a cos t minus plus t sin t into minus cos t. So cos t and cos t, this cos t and cos t gets eliminated, and final value will come out to be a t sin t. Okay, so now let's find the dy by dx. So this will be dy by dt divided by dx by dt. Okay, so now let's put the values of these two. So this will be a t sin t and divided by a t cos t. So here at and at gets eliminated, and sin t upon cos t will come out to be tan t. Now to find out d2y by dx2, let's understand what is higher order derivative. So till now uh, we have higher order in higher order to find out the higher order derivative. Till now we have solved for function y equals to fx, and we were finding y dash, that is equals to dy by dx. This is called first order derivative because here we are differentiating fx for with respect to x only one time. Now if I differentiate this first derivative uh, with respect to x, so it will come out to be double dash, this will be d2y by dx2. Okay, this is called second order derivative, it's its derivative. Okay, moving ahead, so if I again differentiate it, the second derivative with respect to x, so we'll get third order derivative, that is d3y by dx3. This is called third order derivative. In similar fashion we can find it out. Okay, so if we are talking about parametric form, so here it is slightly difficult because uh, we have to find out d2y by dx2, we have to write it like that, d dx of dy by dx. Why I am writing it? Because this function, the value of differential coefficient or first order derivative, is not in the form of x, it is in the form of t. So the value is dx by dt. In the last question it come out to be tan t. So when you differentiate this with respect to x, so this will come out to be sec square t and dt by dx. But we don't know the value of dt by dx, but we know the value of dx by dt. So this will become sec square t upon dx by dt. Now put it. So sec square t whole upon this value was, you can see the this value was at cos t. Okay, so let's put it. So this is at cos t, so this will come out to be sec cube t whole upon at. So this will be your final answer. Okay, let's move to the next question. So 5, let's say y equals to sine inverse x. Now we have to find d2y by dx2. Okay, so to find this, what we will do, we will first differentiate this function with respect to x. So this will come out to be dy by dx, and here differentiation of sine inverse x is 1 upon under root 1 minus x square. Okay, now to differentiate it further, so we'll get second order derivative, that is dy by dx2. So this will be done with like that, 1 minus x square to the whole power minus 1 by 2. So we'll follow the chain rule. First we'll use x to the power n formula. So minus half will come ahead and 1 minus x square, and this will be minus half minus 1. Now we'll differentiate again 1 minus x square, so this will come out to be 0 minus 2x, because differentiation of 1 is 0 and differentiation of x square is 2x. So let's solve it. So here 2 and 2 gets eliminated, minus minus become plus, and this will become x upon 1 minus x square to the whole power. This will be minus half, and minus 1 will become minus 3 by 2, and in denominator it will become 3 by 2. So this will be your final answer. Okay, let's move to the next question. So in next question, I'm going to use exponential and trigonometric function, that is and then I'll follow. Let's say the question is y equals to e to the power x sine 5x. This is the question. Okay, so here I'm going to use product rule. This is first function, this is second function. So for first derivative, let's say I'm writing y dash. Okay, so this will be e to the power x. Differentiation of sine x will be cos 5x into 5. Okay, then we'll write sine 5x as it is, and differentiation of exponential function is e to the power x. So let's take e to the power x as common. So this will come out to be 5 cos 5x plus sine 5x. Now we'll have to differentiate it further to find out the second order derivative. So let's take this as first function and this as second function. So this will become e to the power x, and differentiating this, so this will become 5 and cos 5x will become minus sin 5x minus sin 5x, and we will again differentiate this 5x, so this will be 5. Okay, and plus sin 5x will become cos 5x into 5. Now we'll write the second function as it is. This will be 5 cos 5x plus sin 5x. Okay, we'll write it like that and we'll differentiate first function. So this will come out to e to the power x. Now let's take e to the power x as common. So this will become minus 25 sin 5x plus 5 cos 5x plus 5 cos 5x plus sin 5x. Okay, so let's solve it further. So this will come out to be what? This is 5 cos 5x plus 5 cos 5x. This will come out to be 10 cos 5x minus, here it is minus 25 and plus 1. So this will minus 24 sin 5x. Okay, so this will be our final answer. So till now I have covered here. I have covered parametric form, higher order derivative, and now I am going to talk about first principle derivative rule and nature of differential equation. Okay, so first I will begin with differential equation. So what is differential equation? It is very important. A differential equation is the equation which contains the derivative of dependent variable with respect to only one independent variable. If it contains only a derivative of only one independent variable, it is called ordinary differential equation. And if it contains more derivative of dependent variable with respect to more than one independent variable, so it is called partial differential equation. Here I'm not going to discuss about the partial differential equation, I only discuss ordinary differential equation. Okay, so I have taken three examples. So here these are the three differential equations. Here you can see that we have only taken a dependent variable y and a dependent variable x. So these are the three differential equations. Now two important terms which we need to understand here. What is the order of the differential equation? So order of differential equation is basically highest order derivative of dependent variable with respect to independent variable. So here in this first equation, if we can see that there is only one uh, differential coefficient present here, that is d2y by dx2, and it is of order 2. So here in this equation, this order will be 2. Okay, and in the next example, as you can see that there are two differential coefficients present, which is one is d2y by dx2, another is d3y by dx3. So highest order is d3y dx3. So in this case order will be 3. Okay, now let's talk about the third example. So here in this you can see that there are two differential coefficients and both are of same order, that is 1. So here in this case order will be 1. Now let's talk about the second important term, that is degree. What is degree? So degree is basically highest power of highest order derivative. Now let's understand with these three examples. So here in this case you can see that the highest power of second order derivative is 1. So here in this case degree will be 1. In this situation, if you can see that the highest order derivative is 3, but its maximum power is 2. So in this situation degree will be 2. Whereas if we look at the third equation, so this equation is not in the form of polynomial. Okay, what do you mean by polynomial here? Let's say if I take dy by dx as let's say p, and d2y by dx2 as p square. So all these equation 1 and equation 2 will represent the polynomial form, but this is not in the polynomial form. So here degree is not defined. So keep this thing in your mind. Here degree is not defined. Okay, so remember this thing. If such kind of equation you are getting in your question, so in that situation degree is not defined and order may be anything. If let's say here it is d2y by dx2, so order can be 2. Okay, so that is the thing. Now let's talk about what is homogeneous differential equation. So to understand what is homogeneous differential equation, first we need to understand what is homogeneous function. So a function fxy is said to be homogeneous function of degree n if it is represented in this form, that is f of if I enhance the value of x with lambda x and value of y with lambda y. So the lambda, some power of lambda has to be taken common from the whole expression, and this comes out to be lambda to the power n fx comma y. Now let's understand it by an example so that probably you can understand. Let's say we have function fx comma y equals to y square plus 2xy. So now I'm going to enhance x by lambda x and y by lambda y. So I'm putting the values here. So this will come out to be lambda square y square 2 into lambda x into lambda y. So this will come out to be, now we can take lambda square as common. So here it will come out to be y square in C. Lambda and lambda. That's why I've taken lambda square as common. So here again it will come out to be 2xy. So this is lambda square and this is again the original function. So this function is homogeneous. Okay, homogeneous. And here what does n represent? Here n represents the degree of homogeneity. Degree of homogeneity. Homogeneity. Okay, so remember these things to understand homogeneous differential equation, because in several times the first order homogeneous differential equation has been asked to assess the nature of differential equation. Okay, so first order homogeneous differential equation is in the form of this, where fx comma y denote this function is homogeneous function. So all you need to do is that uh, you have to assess whether the given function is homogeneous or not in order to assess whether the given equation is first order homogeneous equation. Okay, so let's understand it by an example. So let's take dy by dx equals to fx comma y, and this function is, suppose this function is given as x plus 2y upon x minus y. Okay, at the place of this. So this is our homogeneous differential equation. To but to comment this thing that it is a first order differential equation, we have to check whether this is the homogeneous function or not. So let's enhance this x by lambda x and y by lambda y. So this will come out to be lambda x plus 2 lambda y upon lambda x minus 2 lambda y. Okay, so we can take out lambda as common, so this will come out to x plus 2y. Okay, and upon x minus 2y. So lambda and lambda gets cancelled out, this will come out to be 0, lambda to the power 0, and here it is fx comma y. Okay, so this is the thing. So here you can say that the given equation is homogeneous differential equation. Differential equation of order 1. Okay, so this kind of a question can be asked in your IGIDR Entrance Exam. And let's move to the first principal derivative rule. So what is first principal derivative rule? Let's say suppose f is any real valued function. So the derivative can be defined as f dash x limit h tending to 0 f of x plus h minus fx upon h. For now I'm not going to going into detail regarding this, but when we discuss limits, so we'll get into detail, because this concept has come from the limit, so we'll discuss in detail there. Okay, so for now I have covered these two topics as well, first order derivative rule and the nature of differential equation. So now I'm going to cover your inverse function. That is the last topic of the session. Okay, so let's move to the, so in inverse function, generally two kind of question is being asked. Inverse function. Okay, so two kind of question is being asked. One is from differentiation of trigonometric function, inverse trigonometric function, sorry, inverse trigonometric function. And second could be of finding the derivative of inverse of the given function, inverse of the given function. So I'll discuss both in detail. So first I'll discuss differentiation of inverse trigonometric function. So let's take an example. It's example one. Suppose we have given y equals to tan inverse 1 minus cos x upon sin x. Okay. So this is the question. So what I'm going to do here, I'm going to apply half angle formula. So in half angle formula, I'm going to apply these formulas, that is 2 cos square x by 2 minus 1, or we can use 1 minus 2 sin square x by 2, and for sin x we can use 2 sin x by 2 into cos x by 2. Okay, so let's apply. So this will become tan inverse 1 minus, I'm applying second formula, that is 1 minus 1 plus 2 sin square x by 2 whole upon 2 sin x by 2 into cos x by 2. Okay, so now we can eliminate 1 and 1. After this elimination, in the next step, we can eliminate 2 and 1 sin x. So this will become tan inverse sin x by 2 and cos x by 2. So this will become tan x by 2. Okay. So tan inverse and tan gets eliminated and it will come out to be x by 2. Now differentiating this function, the given one, and differentiating this one. So out of which I think this one is slightly easy. So you have to remember half angle formulas in order to solve such kind of question. So here differentiation will come out to be half. This will be your final answer. Let's move to the example number 2. So that is y equals to tan inverse under root 1 minus 1 plus cos x upon 1 minus cos x. Okay, so this is the question. In order to solve this question, I am going to use half angle formula as well as first we'll use half angle formula. So let's say this is y tan inverse under root 1 plus 2 cos square x by 2 minus 1 upon 1 minus 1 plus 2 sine square x by 2. These two formulas I have mentioned in the previous question. Okay, so 1 and 1 gets eliminated here. After this elimination, you can eliminate 2 and 2, and this will come out to be tan inverse under root cos square upon sin square. So this will come out to be cot square x by 2, and this will come out to be tan inverse in a bracket cot x by 2, because this is a square and it will come out of root, so this will become cot x by 2. Okay, so now I'm going to use this formula, that you know that tan 90 minus theta equals to cot theta. Okay, so by that we can write it like that, pi by 2 minus x by 2. Okay, so this is the thing. Now tan inverse and tan gets eliminated, it will come out to be pi by 2 minus x by 2. Okay, so this is why. Now instead of differentiating this, you can differentiate this slightly easily. So this will come out to be y dash will come out to be 0 minus half. So final answer is minus half. Okay, so your differentiation is minus half. Okay, so this way you can solve these kind of questions. So let's move to the another example, example number 3. So this is tan inverse y equals to tan inverse under root, let's say 1 plus sin x upon 1 minus sin x. Okay, this is the question. So for this, what we are going to do, we are going to apply this formula, that is cos 90 plus theta equals to minus sin theta. It has to be minus sin theta. So this is minus sin theta. So at the place of sin theta, what we can write? We can write sin theta equals to minus cos 90 plus theta. So this way we can solve it like that, tan inverse under root 1. Here it will come out to be minus cos pi by 2 plus x, okay, upon 1 plus cos pi by 2 plus x. Now we can apply half angle formula here as well. So this will become tan inverse under root 1 minus 1 plus 2 sine square. Now we are applying half angle formula, so this whole will become half. So this will be pi by 4 plus x by 2. Okay. And in denominator it will come out to be 1 plus 2 cos square pi by 4 plus x by 2 minus 1. So minus 1 and plus 1, minus 1 and plus 1 gets eliminated. And after this elimination you can eliminate 2 and 2. So this will come out to be tan inverse in a bracket under root sine square upon cos square. This will become tan square pi by 4 plus x by 2. So this will come out to be tan inverse tan pi by 4 plus x by 2. Okay. Now tan inverse and tan gets eliminated, so this will come out to be, and finally this will come out to be y equals to pi by 4 plus x by 2. Now differentiate this, so this will come out to be, and this differentiation will be 0 and this will be 1 by 2. So final answer will be half. Now let's talk about slightly different type of question, in which in all these questions what I was doing, I was it was given that tan inverse and some sort of trigonometric relationship. So I'm solving it, then I'm differentiating. Now if you have given such kind of a question, let's say this is example number 4. So this, let's say y equals to sine inverse 2x upon 1 plus x square. If these kind of questions are given, so in that situation what you'll have to do, you'll have to first put something in place of x. So for that you need to remember all the trigonometric formulas. Like here I'm going to put x equals to tan theta, so theta will be tan inverse x. Okay, now put it, so this will come out to be sine inverse x 2 tan theta upon 1 plus tan square theta. So this is the formula of sine 2 theta. So this will become sine inverse sine 2 theta, and sine inverse and sine gets eliminated, so this will come out to be 2 theta, and this will be 2 tan inverse x. Okay, so this is why. Now instead of differentiating this function, you can differentiate this function and result will be same. So this will come out to be y dash 2 differentiation of tan inverse x is 1 upon 1 plus x square. So this will be your final answer. Let's move to the next example, example number 5. So this question has been asked in IGIDR Entrance Exam. Okay, so please be focused. Okay, so tan inverse under root 1 plus x square minus and plus x. Okay, so here you have to put x equals to cot theta. Now you may have question how I'm going to know that what I have to put. So for that you need to practice a lot, and then only you can understand. Okay, so x equals to cot theta, so theta will come out to be cot inverse x. Okay, now let's put it. So y equals to tan inverse in under root 1 plus cot square theta plus cot theta. So this will become tan inverse 1 plus cot square theta is equals to cosec square theta, and cosec square will come out of root and it will become cosec theta. So cosec theta plus cot theta. So tan inverse 1 upon sine theta, cosec theta is 1 upon sine theta, and cot theta is 1 plus cos theta upon sine theta. Okay, so you can write it like that, 1 plus cos theta whole upon sine theta. Okay, so this is the thing. Now again apply the half angle formula, you can solve it. So this will become 1 plus 2 cos square theta by 2 minus 1, and this will become 2 sine theta by 2 into cos theta by 2. Now eliminate 1 and 1. After this elimination you can eliminate 2 and 2, and you can eliminate 1 cos theta by 2. So in the After this you will get tan inverse, and here you can see that cos theta upon sin theta. So this is cot theta by 2. So I have told you earlier that tan 90 minus theta equals to what? Cot theta. So we'll apply that formula. Here it is theta by 2. Okay, so this will become tan inverse tan pi by 2 minus theta by 2. Okay, so tan and tan gets eliminated, and this will come out to be pi by 2 minus theta by 2 y. Okay, so just put the value of theta, so half, this will be cot inverse x, okay, y. Now differentiate this function, so this will be y dash, and differentiation of pi by 2 will be 0 minus half, and differentiation of cot is minus half minus 1 upon 1 plus x square. So this minus and this minus will become plus, and this will come out to be 1 upon 2 1 plus x square. Okay, so moving to the last question of the session, and that is of type 2, which I have mentioned here, I guess. Yeah, that is derivative of inverse of the given function. So this kind of question is asked in the IGIDR Entrance Exam. So I think this will be our example number 6. Okay, so let's say you have a given function y equals to fx, okay, that is x power 4 plus 2. Now first you'll have to represent this relationship as x equals to f of y. So this will come out to be y minus 2 equals to x power 4, and x will come out to be y minus 2 to the whole power 1 by 4. Now you have to find the derivative dx by dy. This is the objective of in this question. Okay, so simply we can solve this dx by dy. That will be y minus we can solve it with the help of simple rule, ddx dy of y to the power n, that is n y to the power y to the power y n minus 1. Okay, so this rule I can apply. So this will 1 by 4 y minus 2 whole to the power 1 by 4 minus 1, and then by chain rule we have to solve it. So differentiation of y with respect to y is 1, and differentiation of constant function is 0. So this has come out as 1 by 4 y minus 2 to the whole power. This power on solving will become minus 3 by 4, and in denominator it will become 3 by 4. So this is your answer. So that's all from my side today, and if you are preparing for IGIDR 2021 exam, whether it is for MSc or PhD, you can enroll in our classroom program. The link is given in the description, and please like this video and share it with your friends, and please subscribe the channel for more updates, and stay safe, stay healthy. Thank you.